I'm doing question number 9 from the exercise 9.3. You can see a figure is given where the two circles are intersecting at two different points, that is B and C. And you can see that through B, lines are drawn, right, touching the two circle at A and D, and through another line segment is drawn, touching the two circle as P and Q. Further, it is joined with C as well, right? So now we get ADPQ respectively are the points where they are intersecting. And what we need to prove here is that angle ACP, that is, we need to prove this angle ACP is equal to QCD, that is this angle. We need to prove these two angles equal. So this question is actually based on the third angle property, which says that if two angles of a triangle are equal to two angles of another triangle, then their third angle must be equal. So let me first shed the triangle, which I'm going to consider. One I'm painting yellow. This is the triangle. One is this. And let's say use some other color to paint the other triangle. Now, these are the two triangles we are considering. These are painted with different colors. Right. Now what you can see that this angle A is equal to angle P, right? That's from the property called angle on the same segment. I can write angle A is equal to angle P. And likewise, I can also say that angle D is equal to angle Q, right? So we have angle D is equal to angle Q is equal to angle Q. Now, what you have to remember that when two angles of a triangle are equal, then their third angle should also be equal, right? This is a property that when two angles of a triangle, so let me write down the triangle. We are talking here of triangle, say A, D, C, and the other triangle taken is PCQ. Triangle PCQ. So what do we know that these are equal from the angles on the same segment? Angles on the same segment, they're equal. Now, as I said in the beginning, that when we know that two angles of a triangle is equal to two angles of another triangle, then their third angles must be equal. So you can clearly see that here these two angles, angle D is equal to angle Q, and angle P is equal to angle A. So therefore, their third angle must be equal. And what is that third angle here? If I see the first triangle, it is angle ACD is equal to the third angle of the other triangle, that is angle PCQ. So you may write down the reason here, that is by third angle property. This is third angle property. Now, what do you realize that the third angle of this triangle is this have been made equal to this, right? So we got these two, but what we have to prove is only this part. We have to prove only these two parts as equal. So we'll be subtracting this angle, that is PCD, from both sides. So I'm writing, we have angle ACD and that is angle PCQ on the other side as equal. So I'm going to subtract this angle at the middle, that is angle PCD, from both sides. Now, if you subtract PCD from the ACD, what you are getting? Let's say in the figure, we have this as ACD, this as ACD. This is what ACD. And if we subtract PCD from the middle, we'll get this angle, that is angle ACP. And from the other side, like this angle, that is PCQ, if we subtract this angle, that is PCD, we'll get this angle as QCD. That is what we had to prove equal. So two properties used here is number one, angle on the same segment are equal. And the second property used here is third angle property. That is, when two angles of a triangle is equal to two angles of another triangle, then the triangles are, when two angles of a triangle is equal to two angles of another triangle, then their third angles are also equal.